waiting for people to join. You can join now. The network is a bit stable. Okay, I can see 4 people. Let's wait for others to join so that we can start. I can see 7 people. Okay, if you can hear me, just let me know on the chat box. Yes, I can see. But let's have seen 6 people joined. If you can hear me, let me. Okay. Okay. So we're going to look at vectors and scalars. Somebody say I was not having data after I struggle with a small that is not working. It's okay. Okay, we are looking at vectors and scalars. So this is a topic that seems to be somehow abstract, but it's not. It's a very simple one. So let's look at vectors and scalars. What is a physical quantity? A physical quantity is that which can be measured. And physical quantities are classified into 2, the vector quantities and the scalar quantities. Those vector quantities are measured in both magnitudes and direction, while those scalar quantities are measured only in magnitude. When we talk about magnitude, we mean numerical values. So the quantities like mass does not have any direction. When you talk about time, temperature, density, these are some of the quantities are measured only in the numerical values without the direction. So when you talk about the vector quantity, like I mentioned earlier, are those quantities that are measured both in magnitude and the direction. But our emphasis here is not on this definition. Our emphasis is how we can represent vectors. Vectors are always represented using arrows. So when you talk about a vector can, we have what we call the four cardinal points: the north, south, west, east. So when they say a vector move eastward, it is moving towards the right, westward towards the left, north and south. And there's one thing we need to know about vectors. Vectors can be added, can be subtracted. For example, please, if you have your pen there, you can be taking down this. If you have vector A moving in the eastward direction, and the magnitude of that vector A is 5 Newton. And you also have another vector B moving in the westward direction, and that magnitude is 3 Newton. These two vectors are moving in the opposite direction. It's what we call the resultant vector. Resultant means the total vector. So it means that when vectors are moving in the same direction, for you to find the total, you add the two vectors. It can be 3. So in a situation like yours, maybe a question will be asked. Maybe they will draw this vector A, vector B, pointing in the same direction. Then find the resultant vectors. Since they are moving in the same direction, you need to add. But the option of subtraction, for example, if vector A is 5 Newton, vector B is 3 Newton, and they are moving in the same direction, the resultant vector in this case should be 8 Newton. But if they are moving in the opposite direction, the resultant vector will be 2 Newton because you are going to subtract them. So in an exam like yours, maybe option A would be 8 Newton, option B will be 2 Newton, and so on. So in this type of examination, you don't expect problems that are so long and difficult. They are simple questions. Even at that, you need to prepare so that you will not be caught unaware. So what I'm saying here is that when vectors are moving in the same direction, you add them, and when they are moving in the opposite direction, you subtract them. And the total is called the resultant vector. What if these vectors are inclined at an angle? For example, vector A is inclined at an angle 90 with vector B. Well, how do you now find the resultant? In this case, they are not moving in the same direction, or they are not moving in the opposite direction, but they are inclined at an angle. That is when, if that angle is 90 degrees, you are going to use a Pythagoras theorem. I'm going to use Pythagoras theorem. Since the network is